Yellowstone supervolcano has a magma lid that could be thwarting eruption. The Yellowstone supervolcano is extremely well studied, but that doesn't mean it is fully understood. Researchers have just discovered a new structure deep beneath Yellowstone, and it might be playing an important role in holding back an eruption from this major volcanic system. Researchers from across the US have been using seismic data and computer modeling to work out the deeper layer underneath Yellowstone. They have found evidence of what they are calling a sharp, volatile-rich cap located 3.8 kilometers, 2.36 miles, below the surface. Basically, this works as a lid to the magma, allowing for gas to be released into the above layers, but keeping the system stable. For decades, we've known there's magma beneath Yellowstone, but the exact depth and structure of its upper boundary has been a big question. Co-author Brandon Schmant, professor of Earth, Environmental and Planetary Sciences at Rice University, said in a statement, "What we've found is that this reservoir hasn't shut down. It's been sitting there for a couple million years, but it's still dynamic." There was a large uncertainty about where the magma was located. The team had to put a lot of work into finding it, as the data was not straightforward to analyze. Collecting the data was also interesting. The team used a vibro-size truck, a vehicle that can send tiny earthquakes into the ground. The team looked at the reflection of these waves to study the interior layers. They comment that the lid appears to be breathing, which suggests it is unlikely that an eruption is in any way imminent. Although we detected a volatile-rich layer, its bubble and melt contents are below the levels typically associated with imminent eruption, Schmant said. Instead, it looks like the system is efficiently venting gas through cracks and channels between mineral crystals, which makes sense to me given Yellowstone's abundant hydrothermal features emitting magmatic gases. The research places a clear structure deep beneath the supervolcano. Future monitoring could focus on characterizing it more. If the structure begins to melt or gas accumulation changes, it might indicate that things are shifting or moving towards an eruption. The approach developed in this work might have applications beyond volcano monitoring. Being able to image what's happening underground is important for everything from geothermal energy to storing carbon dioxide, Schmant said. This work shows that with creativity and perseverance, we can see through complicated data and reveal what's happening beneath our feet. A paper describing the results is published in the journal Nature. Lava fountains for mom? Kilauea says yes. Is there any better gift to give mom on Mother's Day than the beauty, the power, the awesomeness, the sheer amazement of watching creation happen in front of her eyes again? You know, because she did, after all, help create you. Kilauea volcano on the Big Island doesn't think so either, and it's providing the perfect opportunity. Lava fountains for mom. Episode 21 of sustained lava fountaining of the ongoing episodic Halemaumau crater eruption in Kauai, the volcano's summit caldera within Hawaii Volcanoes National Park erupted at 12:45 p.m. Today, May 11th, from the north vent in the southwest portion of the crater. Dome fountain started a new gas piston cycle just less than 5 hours earlier, marking precursory activity to the main event, before evolving into continuous lava fountains. Hawaiian Volcano Observatory reports that fountains rapidly grew into vigorous 500-foot molten rock geysers that ejected from the vent as they fed lava flows that had covered about 10% to 20% of the crater's floor by about an hour later. The south vent was not yet active, but by just after 2 p.m., a look at the live stream showed what seemed to be smaller fountains erupting from the north vent's twin. Sustained fountaining was accompanied by a rapid change from inflation to deflation at the summit, along with a rapid increase in tremor. The Wekahuna tiltmeter recorded about 7 microradians of inflation between the end of episode 20 at about 10 p.m. May 6th and beginning of episode 21, persistent fountaining. Precursory low-level activity to this eruptive phase was marked by gas pistoning events in the north vent, cycling from dome fountaining and ponding of lava to vigorous drainbacks. All current and recent eruptive activity is confined within the national park. No changes have been detected in the volcano's East Rift Zone or Southwest Rift Zone. Hawaiian Volcano Observatory continues to closely monitor Kilauea and will issue an eruption update the morning of May 12th, unless there are significant changes before. News reporter Nathan Christoffel contributed to this story.